Now in this example we want to calculate the pH of a buffer solution. We have been given the pKa of this solution, and we also have been given the acid concentration, and we have the base concentration. And we notice that here the acid concentration is higher than the base concentration, so we can already make a prediction whether our pH will be lower or higher than the pKa. How can we do that? So we can write our Henderson-Hasselbalch equation, pH equals pKa minus log, and we always use the log to the base of 10, of the acid concentration divided by the base concentration. And in the case that acid concentration equals the base concentration, in this particular case, if that is the same, log 10 would be 1. And we can calculate log 10, that would be 0. So if we have this case, pH equals pKa. However, if the acid concentration is larger than the base concentration, then our log 10 of acid over base would be something that is larger than 1. And something larger than 1 would result in something that larger than 0. So here pH would be smaller than pKa. Or likewise, if the acid concentration is smaller than the base concentration, then the pH would be larger than the pKa. And that is quite a useful rule of thumb to make sure that our result that we then calculate is actually correct. So let's do the calculation. So we've got the pH, we are looking for that. We just put the numbers in. pKa is 3.81 minus log of, and for the acid we have 852.3 millimolar divided by 546.8 millimolar. Now the millimolar cancel out, and we can put that into a calculator, and we would get for the pH equals 3.61. And let's just simply check if this is a realistic pH. We said that if we've got more acid than we have base, then the pH must be smaller than the pKa. And 3.61 is smaller than 3.81, so it is certainly a realistic value for the pH. So I hope this makes sense, and thank you very much for watching.